Back to the breadboard. So what are we doing now, Tom?
All right, so what we have here in front of us is the same circuit that we wired at the beginning, and we've got a MIDAC here. And we'd like to look and see if KCL and KVL work with this circuit. So here's my MIDAC, and this is what we're going to use in order to measure voltages on the circuit. Now, if you take a look, I've connected here to the minus terminal of the MIDAC, my black cable, and my red cable to the plus terminal in order to measure voltages. Now, notice I'm not actually plugging the MIDAC into our breadboard. We'll do this in later modules, but for now, we're just using the MIDAC to measure voltages on our circuit.
Okay, so what do you plan to do? My guess is you plan to go around the circuit and look at potentials for the different elements and see if they follow KVL?
Yeah, I mean, what we said about KVL is that the potential that the battery raises electrons should be the same as the potential that drops across the resistor and the LED.
Okay, and so on our computer, we've opened up NI Elvis, and specifically, we've opened up our digital multimeter and set it to measure voltage. Okay, so we're measuring voltage. Let's get to it.
Okay, let's start with the battery. So if I put my plus terminal on the plus and minus on minus, we measure 8.3 volts.
Wait a minute. Isn't that a 9-volt battery?
Yeah, well, that's all right, because batteries, as they expend energy moving electrons up, their potential, they start to lose their potential over time.
So this is a used battery. It's a little bit used.
This is not fresh off of the factory.
Okay, good enough. Actually, it's better because the number is not nice and round. So 8.3. So that tells me that you've taken an electron and raised it up by 8.3 volts, and then it's going to go through the resistor and the diode. So the sum of the resistor and the diode better be a drop of 8.3 volts, right? Because we're coming back down to where we started.
Absolutely, absolutely. Right. They should add up. So why don't we look at our resistor? So we put our minus terminal here and our plus terminal of our voltage here.
Minus 6.04 volts across the resistor. We've dropped down by 6.04.
Now, what's the drop across the LED?
Well, let's take a look. Let's measure the same way.
Aha, minus 2.24.
Okay, that works. So that means we went up by a certain amount using the battery, which is what we expected, and then we went down as we went through the resistor and down further as we went through the LED and ended up back where we started.
Exactly where we started. We dropped exactly the same amount.
Now, I noticed when you're measuring potential, you're using 2 points. So is that always true of potentials?
Yeah, so potential is actually always measured between 2 points on your circuit. It doesn't really make sense to say there's a voltage at a single point. Potential is always measured between 2 points on your circuit.
Okay, so like when an engineer, though, maybe sloppily says, that wire is at 4 volts, they really mean that wire is at 4 volts higher than some reference that he or she happens to know about when they're talking.
Yes, and they should be talking to someone that understands what that reference is.
Right, exactly. Okay, so we're almost done, but I can't resist. I know we're not going to prove KCL sort of using the MIDAC, but I understand from KCL that if I add another branch, right, I should have electrons flowing down that branch. So what if I were to come in with another LED and put it right where the first one connects and also on the bottom? Oh, I think I put it in backwards. Let's see. Did I put it in backwards? I did! Look at that. And so now current's coming through the resistor and then splitting by KCL. It's going down both. You know, some of it's going down one LED and some of it's going down another LED. Okay.
Yeah, it looks like the current was shared between the two. And even when you plugged it in, it may be hard to tell on the video, but if you do this at home, you can tell the LEDs are both getting a little bit
Oh, that's right, because now you're splitting some of that current. Okay, so fair enough. We've learned KVL, KCL, and a little bit about some basic elements. We'll see you pretty soon because we're going to dig into resistors, and bear with us. Right after that, we're going to start building parts for our little robot.
Awesome. See you then.
All right.